Welcome to Homework Lib.
A plane that has a speed of 150 meters per second. This is the magnitude of the velocity of the plane. And we're told that we have a constant wind blowing south. Velocity of the wind is which is going to have a value of 30 meters per second going south. So going on the negative y-axis, so minus j unit vector. What we want to know is in what direction must the plane fly relative to the air if the velocity of the plane needs to be constant. So to do this, what we want to get is that the sum of the vectors of the velocity of the plane with a certain unknown angle and the velocity of the wind that is going down. Sorry, over here, let me correct it a little bit because the plane is going west, right, instead of east, and I draw it as if it was going east. So, in this case, if it's going west, the velocity of the plane would be here, and this is the angle that we need to calculate. So, the sum of the vectors, what we need to get is that the sum of the velocities on the y-axis needs to be equal to 0 for the plane to have only a component on the x direction, and that would be on the negative x direction. So, for doing this, what we know is that the velocity of the wind corresponds to minus 30 meters per second on the y-axis, and if we want to calculate the y part, the y contribution coming from the velocity of the plane, we want to employ the sine function because this is the opposite cadet and we know the value for the hypotenuse. So in this case, sine of theta would be the opposite cadet divided by the velocity of the plane. This is going to be the velocity of the plane on the y-axis divided by the velocity of the plane. Thus, velocity of the plane on the y-axis is going to be equal to velocity of the plane times sine of theta. This is going to be a positive value, as you see from the drawing. We're on the positive y-axis. So we're going to get plus velocity of the plane times sine of theta. This is also, sorry, in the j-axis over here. J, not I. So from here, what we can say is that velocity of the plane times sine of theta needs to be equal to 30 meters per second. Velocity of the plane is equal to 150 meters per second. Thus, the value for sine of theta is equal to 30 divided by 150. From here, theta would be arc sin of 30 divided by 150. The value for theta is 11.54 degrees. So if we look back at our drawing, this value would be 11.54 degrees north of west. And comparing this to the answers that are given to you, it would be the second one, 11.5 degrees north of west. So that would be all. Thank you very much and have a good one.